Disclaimer, this video does not make sense. Don't actually attempt the math in this video, you may be arrested. Hello, and welcome to a budget version of meme math. School took away my copy of Adobe Animate, so now I'm using paper. Today I will be talking about a really stupid function that makes no sense called the holy function. The holy function is a function that has a hole at every point. So, to arrive at this function, first we'll start with y equals 1. That's y equals 0. Obviously, the graph of y equals 1 looks like this. So to make a hole, you do the following. At x equals 0, y will equal 0 over 0, which is undefined. So there will be a hole at that point. Now, if we want to move the hole, we can subtract by the x value which we wish to move it to. So for x equals 1, we get that y is equal to 1 minus 1 over 1 minus 1, which is 0 over 0, which is undefined. So there is a hole at x equals 1. Therefore, we can say that to have a hole at any point a, we can just say that y is equal to x minus a over x minus a. So to have multiple holes, you can multiply two of these fractions that give holes together. So if we want to have a hole at point a and point b, we can do the following. So, for a function that has a hole at every point, we want infinite holes. Therefore, we can use an infinite product This function will have a hole at every positive integer from 0 to infinity. So to decrease the distance between the holes, we can divide m by some number. So dividing m by 2 will halve the distance between the holes. So what we want to do is make it so that there's an infinitely small distance between the holes. Therefore, we can write this as since n is approaching infinity, the distance between the holes approaches 0, so there's a hole at every point. This will give us a graph that looks like this. You may think that this is done, however it's not. So, if you look at the other side of the graph, there's actually still a straight line. There's actually still a defined line. Because the product only applies for positive integer values of m, not negative values, so we want to add something to make m also negative. This means that we can add a negative 1 to the m term. Well, ordinarily, this would mean that the function alternates between positive and negative holes. Since the distance between the holes is infinitely small, it actually doesn't matter. There's still a hole at every positive and negative point. Okay, if this math wasn't memey enough, here's where the real meme math comes in. We're now going to be doing arithmetic with infinity, which clearly is a thing. Disclaimer, this video does not make sense. Don't actually attempt the math in this video, you may be arrested. You may think that this function actually outputs holes at every point. However, you would actually be wrong, because if we start treating infinity as a number, we can see that the highest value that you'll reach in the fraction whole term is x minus 1, because you'd have infinity over infinity, which means that the function would actually just look like this. Therefore, we can define the function as This means that even at the maximum value of m, you'll still be dividing infinity squared by infinity. So if we treat infinity as a number, then you still get infinity, which means that there is, in fact, a whole at every point. Additionally, if you wish for the Holy function to follow some other function, you can multiply it by that function. So the final Holy function that we get is, I'm going to use phi to notate the Holy function because it looks like a whole, and also a 0 being divided because you're dividing by 0, and also a halo for Holy function, and also it's like a don't do this sign because the math in this video is dumb, so you shouldn't do it. Anyways, point is, so the Holy function of some function of x is equal to f of x times the Holy function, which is the limit as n approaches infinity of the product from m equals 0 to n squared of -1 to the m times x minus m over n over x minus m over n. This is the finished Holy function. Enjoy.